Hello, welcome back. In this video, I'll show you how to find the tangent line of 2 space and 3 space curve. So let's recall back your memory in finding the tangent lines of 2 space curve. Let's look at this curve. Let's imagine you have been given an equations y equals to fx, and you need to find out the gradient at the point of interest of 4 and 5. So what is the gradient or the slope or the steepness of the curve at this particular point of interest? You know, when you have been given y equals to fx, and automatically the gradient at this particular point will be the dy dx, the derivative of the y towards x, or you can write it in this form, f prime x, and to find out the point of interest, the gradient here will be f prime 4. And if you look at the gradient here, the gradient of this point is actually a straight line with a certain slope, and the gradient is the delta y divided by delta x, which means that the change in y divided by the change of x. Now you get the gradient, and how to find the equations of tangent line. Recall back from your most common straight line equations, y equals to mx plus c, and you have the point of interest where you get the value of y equals to 5 and the value of x equals to 4, and you have the m, which is the steepness or the slope of the line at that particular point of interest. In this case is the delta y divided by delta x and plus c. C is the constant, where in this case it is the intersection of the y axis. So I want you to focus on this y equals to mx plus c. It's the gradient or the dy dx or the f prime of x, and x is the parameter, which is the independent parameter. Y is dependent parameter, which means that y depends on the value of x. Now we move on to position vector value functions. If you are given rt equals to xti plus ytj, which means that the position vector depends on the position of x coordinate and y coordinate, and both of these x and y coordinates depends on the parameter of t. Let's assume t is the time. So how to find out the gradient or the slope of the particular point of these position vector value functions? So to find the gradient is actually similar to the concept of 2 space. You need to differentiate it, r prime t, and when you differentiate the r prime t, you need to differentiate the x and the y component together. And if rt is equals to position vector, then the slope or the gradient of that particular point of interest is actually delta r over delta t, which means that the change in the displacement divided by the change of time, which is equal to the velocity v and t. So look at the similarity between the 2 space and 3 space. The delta y refers to the change of the dependent variable, and the delta x refers to the independent parameter. In this case, the delta r refers to the dependent variable, and delta t is the independent variable, the parameter. So when you differentiate the rt, you will get the gradient or the slope or the steepness at particular time, which is the velocity vt. So what is the formula of the gradient line at a particular point on the curve of rt? Now compare with the 2 space gradient line here, y equals to mx plus c, and the rt equals to vt naught t plus r. We know that the y is the dependent parameter, and here rt is the dependent variable, and x is the independent variable or the parameter. And here in the 2 space curve we have t as the independent parameter, so we write the t here, and we know that the m refers to the slope or the gradient, so we have the vt here corresponding to the slope or the gradient of the vector value functions, and we plus a rt naught, which is corresponding to the constant here. So why do we select t naught? T naught because we want to know the slope or the gradient at that particular point of interest. In this case, the point of interest refers to the time of interest, T0. So we substitute T0 into these equations. Just like how to find out the constant C here, you substitute the values of the point of interest of y and x here. And this is how you get the tangent line of a particular point on the 2-space or 3-space curve. I have some exercises in the self-assessment test, so maybe you can try it out on your own to check whether you understand this concept or not. If you have any problem regarding this tangent line of a particular point on a 2-space or 3-space curve, please feel free to pause in the comment sections so that your friends and I can help you to solve it. Thank you and good luck in trying it.